Welcome to the CBSE MathSmith. Today, we'll unravel the mysteries of quadratic equations, their significance, applications, and how to solve them step by step. A quadratic equation is a polynomial equation of the second degree. Its standard form is ax squared plus bx plus c equal to 0, where a, b, and c are real numbers and a cannot be 0. Here are some examples of quadratic equations. Quadratic equations are everywhere, from architecture to physics and even business decision-making. There are three common methods to solve quadratic equations: factorization, completing the square, and the powerful quadratic formula. Factorization involves expressing a quadratic equation as a product of two linear factors and setting each factor equal to 0. Let us now look at the steps involved. Step 1. Write the equation in the standard form ax squared plus bx plus c equal to 0. Step 2. Find two numbers that multiply to give a into c and add up to b. Step 3. Split the middle term using these two numbers. Step 4. Factorize the expression into two binomials. Step 5. Set each binomial equal to 0 and solve for x. Let us now solve the quadratic equation 2x squared minus 5x plus 3 equal to 0 using the factorization method we discussed earlier. Completing the square involves rearranging the quadratic equation into a perfect square form and then solving for x. Let us now look at the steps involved. Step 1. Start with the standard form ax squared plus bx plus c equal to 0. Step 2. Divide the entire equation by a if a is not equal to 1. Step 3. Move the constant term to the right side of the equation. Step 4. Add the square of b divided by 2a to both sides of the equation. Step 5. Rewrite the equation as a perfect square in the form x plus p whole square equal to q. Step 6. Solve by taking the square root of both sides. Let us now solve the quadratic equation x squared minus 4x minus 5 equal to 0 using the completing the square method we discussed earlier. Quadratic formula is a universal method that works for any quadratic equation. The solution is given by the formula minus b plus or minus square root of b squared minus 4ac divided by 2a, where b squared minus 4ac is called the discriminant. Let us now look at the steps involved. Step 1. Identify a, b, and c from the equation ax squared plus bx plus c equal to 0. Step 2. Substitute these values into the formula. Step 3. Simplify under the square root. Calculate the discriminant. Step 4. Solve for the possible values of x. Let us now solve the quadratic equation 2x squared minus 4x minus 3 equal to 0 using the quadratic formula method we discussed earlier. The discriminant of a quadratic equation determines the nature of its roots. If positive, there are two distinct real roots. If 0, the roots are equal. And if negative, the equation has no real roots. Let us now look at a practical problem. A plot of land has an area of 528 square meters. The length is 1 meter more than twice the breadth. Find the dimensions of the plot of land. Let the breadth be x meters. Then the length is 2x plus 1 meters. Therefore, using area of rectangle is equal to length into breadth, we get x into 2x plus 1 equal to 528. Rewriting this equation in the standard form of a quadratic equation, we get 2x squared plus x minus 528 is equal to 0. We can solve the quadratic equation 2x squared plus x minus 528 equal to 0 using the factorization method that we discussed earlier. Since length or breadth can't be negative, we can ignore x equal to minus 33 by 2. Therefore, we get x equal to 16 meters, which is the breadth, and 2x plus 1 equal to 33 meters, which is the length. To recap, in this video we covered general form of a quadratic equation, methods for solving quadratic equations, and relationship between discriminant and type of roots. Thanks for watching. If you found this video helpful, please give it a thumbs up, share it with your friends, and don't forget to hit the subscribe button so you never miss out on more math tips and tutorials. Be sure to check out our other videos for more topics and detailed solutions to challenging problems. See you in the next video. Happy learning!